Okay, Mystic, when you say you don't hear anything, is it literally you don't hear anything? Or is it, do you just not... Oh, you did hear some... Okay. I guess Spotify was kind of acting up. Ah, the wonders of pretending to be a streamer. Audio issues all the time. Do you hear the song now? All right. Try something. All right, there we go. Also, the wonders of having a knob on your keyboard. Oh, hang on. Check 1, 2. Another decibel to the mic. Okay. There we go. So, after yesterday, or yesterday, when was it? When was it? Wednesday? Well, knowing the time zone Mystic is in, it's probably probably was Thursday over there. Like real early Thursday in the morning. Weird time slots. Get in a real time zone, Mystic. Anyway. Already tomorrow / today / yesterday. Yeah, it's we should all just move to Swatch internet time, right? Everybody moves to Swatch internet time. I'll see you at 372 beat. If I can fool around a little bit. I have to mess with some windows. And set this window. There we go. Low cargo. So I'm thinking that from where I stand now, maybe it is a better idea to just go ahead and go through the Rust book itself. You know, if you read the title of the stream, maybe that would be obvious. Turn off. Trying to render 2 frames at once. What are you doing? All you have is a 59 DX. It's not. It's. What are you trying to do? Overstress your machine? Anyway, I've got this. Oh, hang on. Let's see. Yeah. Go. Make that visible. Hey, how's everybody? There's our development window. And there is our. Let's see. Instead of using my mouse to actually control whether or not. Actually, should I just. Maybe I should kind of sort of full screen that and see what happens. Oh, no. Oh. And if I full screen it. That's not a bad effect. And I can control that from my phone because I downloaded an app that does the that does the WebSocket shit. Just slide it in. Actually, let me see if I can hide transition, slide left. See if I like that effect more. It goes in and then out. Awesome. All right. So, let's bring up the Rust book. Let's get started. Installation. First step is to install Rust. We'll download Rust up. We've already kind of done that, but go ahead and do it. If you want to install Rust up on Linux or Mac OS, you want to run that command there. Now, I actually have run Rust my own operating system, Arch Linux. I just did Pacman Tech capital S Rust. Pretty sure that's what I did. If I didn't, I'm lying and should never believe anything I say ever again. But I have to imagine most Linux distros are going to have it's a good. There we go. Now it's not blocking now chat's not blocking the actual text of the book. What am I thinking? Most cases, your distribution, your operating system should have a way to install Rust itself. So, let's see. Here we go. What if I just turn off the noise gate? There we go. So we say the command downloads a script and starts the installation of the Rust up tool, which we've already done. You will need a linker, which is a program that Rust uses to join its compiled outputs into one file. It's likely you already have one. If you get linker errors, you should install a C compiler, which will typically include a linker. A C compiler is also useful because some common Rust packages depend on C code, and you will need a C compiler. Just about every language on the planet at some level drills down to C. Everyone writes a new language inside of C, and then they just write the interpreter or compiler. Mac OS. On Mac OS, you can throw your machine away and get something with Linux. Installing Rust up on Windows. Well, the first step to installing Rust up on Windows is installing Linux, and then you scroll back up, and you install on Linux. So, troubleshooting. Oh, that's right. We had some kind of problem yesterday, or the last time I streamed, where the unfortunate reality was that I didn't have things added to my path. But I'll worry about that later. Updating and installing. Okay, so local documentation. All right, so that's step 1 installation. Hello world. All right, creating a project directory. We're gonna skip this because we do know that the best way to start a project directory is gonna be the, hello, wait, hang on. 2 files with PowerShell and Windows. Compiling and running are separate steps, okay. Newly created program. See the executable. Same 3 files that you would see using CMD. The fact that I saw main.exe, main.pdb, and main.rs. So there's the source. There's the compiled Windows binary. So I'm gonna ignore that. Is there a what's the PDB file actually? File containing debug information. That's good to know. If your main.rs is your hello world program, This line prints hello world to your terminal. Okay. Programming a guessing game. So, setting up the new project, cargo, new guessing game. Okay. So let's go ahead and cargo, new guessing game. We created the guessing game. And let's go ahead and get inside our source directory here. So from there, first command takes the name of the project as the first argument. The second command changes into the process. Okay, so we instantiate a new guessing game project, and then we just go into the directory that that cargo just created for us. The first command, yeah. And then we take a look at the cargo file. Let's go ahead and take a look at the cargo. There's nothing here. Okay, so the name should be guessing game. 010 edition should be 2021, right? It is. As you saw in chapter 1, there's the file name. Now let's try and run it. So we are in Tmux, so let's just make a new window. Bring this down here. Guessing game, cargo, run. And it printed hello world for us. Nice. So then the next step, processing a guess. So we want to use standard IO. We want to guess the number. Actually, let me play a little bit more center to screen. Yeah, I like that. There we go. So we have guess the number. We use standard IO. We say guess the number. We print line, please input your guess, and then we create a mutable guess variable. And it's just going to be an empty string. Take the standard in, read the line, and then we .expect. I'm going to guess .expect is definitely part of the... I mean, it's inside of the read line. And I don't know what the language is here. Is it class? Really weird language. But basically, if it fails to read the line, you put read line .expect, and if it fails, that's what it prints. And then you print line you guessed, and then I guess this is the formatting. Squirrely bracket inside of guess. Okay, so let's just go ahead and copy that. Go back into Vim. Let's see. Nope. Main function not found. I'm just going to copy that again. Unmatched squirrely. That's weird. So if we do cargo run, please input guess the number, please input your guess. 3. And you guessed 3. Okay, awesome. Back to our book here. Code contains a lot of information. We're using the standard IO. Set of items predefined. Type you want to use isn't in the prelude. You have to bring that type into scope explicitly with a use statement. Okay. So that's your sort of import statement from Python if you're familiar. Number of useful features, accept user input. Good, good, good. All right. So we say, so print line, I think this is the part where it says this is a macro. If you see the exclamation point, it's not actually a function, it's a macro. Means there is a function somewhere out there. This code is printing a prompt, storing values with variables. Okay, next we will create a variable to store this input. What's happening here? Something's up with my That is some really weird behavior out of Spotify. It is occasionally not outputting audio into both of my headphones. That is fascinating. Going on in the line. Use let. So let apples equal 5. Oh, actually. Immutable, immutable. Actually, let's bring that back up. Because that's one of those that I'm going to need very often. So the guess variable, which is an empty string at first, is mutable. Program's getting interesting. There's a lot going on in this little line. We'll use the let statement to create the variable, which feels like JavaScript in a way. I'm used to declarations either being the type, or like in Python, you don't even need a declaration of a type. A declaration. You just say, here's the variable name, here's the value, and the interpreter figures it out. Let is a little bit new to me in that it's a little reminiscent of JavaScript. Returning to the guessing game, let mute guess will introduce a variable named guess. The equal sign tells Rust we want to bind something to the variable now. On the right side of the equal sign is the value that guess is bound to, which is the result of calling string new. Function that returns new instance of string. Okay. Colon syntax. Indicates that new is an associated function of the string type. Got it. In full. Okay, yeah. Okay, we received user input. We included the input-output functionality from the standard library with use standard IO on the first line of the program. Now we'll call standard in function from the IO module, which will allow us to handle the user input, which let's see. Yep, you can see it right there. IO standard in, read line, and it'll cover .expect here in just a second. If we hadn't imported the IO library, with standard IO. We would still use the function by calling it, but we'd call it standard IO standard in. Standard in function returns an instance, which is a type that represents a handle to the standard input. So we call the readLine method. The ampersand indicates that the argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. So that's so it operates a little bit like a pointer in C, but Rust is a lot more anal retentive. I'm kind of starting to understand. About like here is a thing and it is owned by that name. Access one piece of data without needing to copy that data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Hence, you need to write reference mutable guess rather than reference guess to make it mutable. Actually, now that I see that, I'm very interested in the distinction between borrowing a mutable rather than just giving ownership. That's something that I'll need to keep for my separate, I'll have to make a note on that separately. I don't really grasp the difference between mutable, referenced, as opposed to just going ahead and giving ownership of the thing inside the thing. Okay, handling potential failure, we say .expect. Could have written this code as a single line. One lone line is difficult to read, so it's best to divide it. I agree. It's often wise to introduce a new line and other white space to help break up long lines when you call a method with the method name syntax. And that is why... Oh, my desk is crowding me out here a second as I rearrange things. And that is why you see... Let me see if I can... And that is why over here, because you don't have a mouse cursor, I have this over here, which is column 79. Column 79 tells me, hey, you should probably think about making a new line rather than continuing to write on this line. I'm a big fan of a hard break. A hard line break at, a hard limit of 80 characters per line. Big fan of that. Mostly because, even though you guys see... Let me see if I can... It's doing it again. This is weird. Even though Spotify is outputting both... Even though Spotify is outputting only one, it's interesting that... it seems that Spotify is outputting both channels to Twitch, but it's only outputting one channel to me. Does that show up on... Hang on. Oh. Oop. Where is... Okay, that is actually really fascinating. Now, does the QPW graph window... Okay, here we go, yeah. So check this out. QPW graph, which is the audio to both my audio channels and how I manage what audio goes where. Spotify is supposedly going to my headphones in both channels right now, but I'm mysteriously only receiving things in my left ear. That's definitely an issue that's I'm gonna need to track down. I will say I wasn't having this issue. I did update Spotify fairly recently. That is really weird. Anyway. Technical issues. Ladies and gentlemen, I'm deeply sorry. Programming guessing game. There we go. Close that. So, however, one long line, difficult to read. We break up really long lines. Chapter 6. Okay, here we go. Read line puts whatever the user enters into a string we pass to it, but it also returns a result. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Chapter 6 will cover enums in more detail. Okay. The purpose of these result types is to encode error handling information. That's definitely something to keep in mind for the future. Definitely something to make a note of, because in one of my projects I've been running up against like, oh yeah, it's not returning the value, it's returning a container which will either itself have the value and you have to grab it from there, or you'll have to grab it. What you grab out of it is actually error information. And that's what they're saying here. Results variants are either okay or err. The okay variant indicates the operation was successful, and inside of okay is the successfully generated value. The err variant means the operation failed, and err contains information about how or why the operation failed. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. If the instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. So that's good that's you're already working on error handling. Which, man, that was like, I don't know how, when I was still taking classes back in college, I don't know how early we were expected to start worrying about error handling. If this instance of result is an okay value, expect will take the result. Expect will take the return value that okay is holding and return just that value so you can use it. In this case, that value is the number of bytes in the user's input. Wait. The number of bytes. If you don't call expect, the program will compile, but you'll get a warning. This result may be an error variant which should be handled. Okay. Rust warns you that you haven't used the result value. Okay, so, and then we print line. This is just the basic printing. And it's teaching you that squirrely brackets are the sort of format. And if you print, there's your string literal. And then there's your y+2. But if you have empty squirrely brackets, it's going to use the y+2 value. So that would be 12. X equals 5. So x equals 5 and y+2 equals 12. So testing the first part. We've already tested. We've already run this code. First part of the game is done. So we generate a secret number. So we use a crate to get more functionality. Okay, so this is where we do the actual import library kind of stuff, but they're called Sully the Cat. First, Rust style is to indent with 4 space. Is that in the book? 4 spaces? Ah. Wait. I lost it even though I had it. Okay. As you can see, wait. Oh, did I scroll way down? I guess I did. Yeah. Yeah, that's pretty standard. Wait. You can't take Rust seriously because you indenting is 4 spaces instead of a tab? Okay, that might take some explanation, Sully. What's wrong with instead of tabs, spaces? I'd do that anyway. If you're some kind of monster that actually uses tabs, I don't know that we can indent with tabs, align with spaces. See, but then if you okay, hang on, what's happening here? No, you indent with spaces, where basically you've just replaced tabs with 4 spaces. Are you not using a monospaced font? What's happening here? Because if you indent with spaces, you're already aligned. But like, why would I'm struggling to come up with a justification for why you would do things like, oh, just you indent. Like, why do you need to align if you're indenting correctly? Even if you're using tabs, I'm granting you. If you indent with tabs, other people can still read the code with different tab width. But if you indent with spaces, like none of that changes. Like, hey, I mean, universally, you just say, hey, a tab is either 2 spaces or 4 spaces. 2 spaces on Python because Python has some nasty habits, but like I just have a script right here that says anytime I hit the tab key, I just insert 4 spaces. That doesn't mean they're always stuck with your 4 spaces and can't change it to 2 or 3 if that is their preference. I see. Your reasoning is a little bit more reasonable. Slightly more reasonable, but I still think tab people are monsters that deserve to get thrown in the pit. Tab width at 3? Why? I guess middle ground between 2 and 4. Whatever. This is you are breaking parts of my brain I didn't know I had. All right, where was it? Where was I in this? Okay, printing values. So we already printed the values. So we're generating a secret number. We're using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code that is intended to be used. What? This is frustrating. This Spotify only going into one of my ears shit is really starting to get on my nerves. Let me... And it's looking in my configuration, my audio configuration. And it's got like staticky. That is, it's, Very odd. Very, very odd. It does. I'm working on wrapping only one major compiler to worry about package manager. I mean, yeah, Python has a lot of that too. Yeah, I'll agree there. Numerics like U64, you get like I mean, I don't know about that. I don't know about being a derp language. There's a lot of value in the fact that you can write what looks a lot like pseudocode and have it actually work and have it actually output things that you want to see. Anyway, so the book is saying we're going to import 0.85, 0.8.5. So let's go back over. So we're in dependencies. Save that. Simple enough. Let's go back to the main, where I have my types out where I can see them. Yeah. I have a lot of appreciation for Python, JS. So like so what is your, so you're a little bit more of a C guy and probably a lot more embedded too, where you like to think of every single variable as it is this in memory at this memory location, and it takes up this many bytes in memory. Like you're that kind of guy. I kind of used to be, and I still am a little bit if I ever get back into embedded stuff. If I ever get back into embedded programming, I'd like to see. I see a lot of people are doing embedded with Rust. Where was I? Okay. So we're back. We imported the rand library, quote unquote. In the cargo toml file, everything that follows a header is part of a section that continues until another section starts. In dependencies, you tell cargo which external crates. Let me see. I know I'm hijacking my own stream, just dealing with audio shit. I'm very interested to know if the song is actually doing the same thing to all of you as it's doing to me, because every time a song switch happens naturally, not every time, but it's happening pretty regularly, the song will only come out to me on the left channel, but if I manually switch tracks, then goes back to both ears. Right now, I'm only getting left channel in Spotify. Is anyone else in chat? I think it's Spotify issues more than Linux issues. Because it wasn't doing this last time, and last time I hadn't updated Spotify. Okay, now I seem to be getting both. Well, they're a lot better now, especially now with Linux audio drivers are a lot better now that we have Pipewire, and we don't have to use Pulse Audio. And Pipewire lets me do amazing things, especially inside of the stream. So let's put a Spotify window way down there. Pipewire is basically not hard to explain. It's called the audio server. I don't even know that I'd call it the drivers, because it's not drivers. But if you've ever heard of Pulse Audio being a clusterfuck, we largely fixed that. And a feature of Pipewire, in fact, let me just show you this, because this is actually really cool. Do I have... All right, so I have this I have the secondary program that's really just a front end. Where is... Where is it? No. No. Really? Does it not... Can it not find it? There we go. Okay, now I can show you the window. This is QPW graph. It is part of my main Pipewire-based setup for controlling my audio. I can zoom in, and I actually have all kinds of... Here is the source. You see the two Capture FL, Capture FR. That is my microphone, and my microphone is going to OBS Studio. And I also have Spotify. Spotify is going... Where is that going? Oh, because I opened up Pabu Control. Let me close Pabu Control there. So I have Spotify going both to my actual headphones, which these are my headphones. And then this is actually a specific audio source that I can set up in OBS. So I can independently control my mic audio inside of OBS, and I can control Spotify audio inside of OBS. My favorite thing is that this is actually independent of the actual audio inside of OBS. So I can turn Spotify up for you guys, but it's not doing anything for me. I can turn it down for stream, and I'm not seeing any change in the volume. I can turn it up for me, and you guys are noticing there's no volume change in the music. I can turn it down for me. I get really fine-grained control over my audio, and I love it. All right, so let's get rid of that, and let's get our Rust book back, and I'll close QPW graph. Oh, okay, so Cargo Tommel. Everything that follows is... So it's basically like if you've ever seen streamers complain about voice meter. Well, shit. But they have to use voice meter so that they can control audio from like Discord versus, you know, this and that and whatever. Probably my favorite thing about Linux is that like I can use Pipewire, and it's just a native functionality of Pipewire. Okay. In the cargo file, everything that follows a header is a section. We specify the rand crate with the semantic version specifier that we want, 085. Cargo understands semantic versioning. I don't know what... It's like Is there something specific? Major version when you make incompatible API changes. Minor version. Oh, okay. Major, minor, and patch. Okay. Okay, that makes sense. It does seem very, very nice. Oh God, does C even have a package manager at all? Are they? I have to imagine someone has tried to make a C package manager. VC package. The specifier 085 is actually shorthand for caret 085. C has no official well, hardly any language has an official package manager. Like, as much as we say like npm, basically everyone uses npm, even though no one wants to use npm. It's not the official package manager of JavaScript, but it might as well be. Pip. I'm pretty sure pip has nothing to do with Python. Pretty sure pip is technically separate from Python. But then again, maybe cargo is too, because like, you know, in step 1, installation, like installation says, oh, okay, here's Rust up. And so you're using Rust up to compile, I think. Yeah, there's Rust C. I guess you can say basically official. But there's ways to make it way more complicated than it needs to be, at least. I'll tell you what, I actually need to... the official book needs to advise... That's true. The official book advises using cargo. Alright. I actually need to stand up and take a small break. Suddenly I need to take a little bit of a bio break. So I'm gonna go put the beer right back up. Let's move that over. Let's move that up there. And hide the browser window for just a second. I will see you guys in about 5 minutes, 10 minutes? We'll see. I have returned. I am back. Get rid of that. Oh man. Sometimes a moment of gastric distress overtakes you, and you need to deal with it right now. But I will leave it at that. Don't need to distress any of you any more than you have been already. Anyway, let's go ahead and so C has official VV. Oh wait, no. Upload pics. That's not something we want to do today, is it? You don't need to. You don't need to. You don't need any of that in your life. Anyway, oh, did I not? Oh, I got rid of that. What am I? Okay. Yep, and let's do that. So, programming a guessing game. Let's jump into Rust by working through hands-on project together. Caption it Taco Bell, am I right? And it's all good. I'd rather not end up banned on these platforms. That's for the secret Discord channel. The secret channels. Which, by the way, if you want to join the Discord, discordamperature.com. And that should link you to an invite that goes right to it. This is so weird. Oh, this is gonna that's gonna drive me nuts. It is actually gonna drive me insane. You may see me suddenly pause and then unpause the music tracks. Anyway, working through a hands-on project together. Hooray! This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. Let, match methods, associated functions, external crates, and more. Wait. We are, oh my god. Okay, generate the number. Now, without changing any of the code, let's build the project. So, we go down here, cargo build. Yeah, it is compiling a hot mess of things. So back to our code. Yep, we downloaded rand, we downloaded libc. I guess that makes sense. Get random, config if, ppvlite. Compiled that, and we did a whole bunch of shit. You may see different version numbers, but they will all be compatible with code thanks to semantic versioning, depending on the operating system, and the lines may be in a different order. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from crates.io, which is that's just the sorter repo. That's the repo. It's where people in the Rust ecosystem post their open source Rust projects for others to use. Oh, isn't that nice? Isn't that sweet? So after we update the registry, Cargo checks the dependencies and downloads any crates listed that aren't already downloaded. In this case, although we only listed rand as a dependency, Cargo also grabbed other crates that rand depends on to work. After downloading the crates, Rust compiles them, then compiles the project with the dependencies available. Let me try something else real quick. I'm going to load up the website, Spotify.com, on my browser. I'm going to close the actual native client. I'm going to open QPW Graph once again. And I'm just gonna... I'm gonna see if that fixes it. My bad. Oh. There we go. I think I may have ruined some people's times there. Sincerely sorry. I accidentally sent Spotify over to my microphone audio input rather than my Spotify audio setup, which should have had a lot of volume reduction applied to it. The wonders. Anyway, if you open the source main RS file, make a trivial change, then save it and build it again, you will only see 2 lines of input, okay? Which means... Oh. So we'll do print line... Hello, I'm a trivial change. And then we build it again. And we only had to compile the actual code that we run. That's good to know. These lines show that Cargo only updates the build with your tiny change. Your dependencies haven't changed, so Cargo knows it can reuse what it has already downloaded and compiled for use. So we want to ensure reproducible builds. Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the versions of dependencies you specified until you indicate otherwise. Say that next week version 086 of the RAN crate comes out, and that version contains an important bug fix. God, I sound like Huni. But it also contains a regression that will break your code. To handle this, Rust creates the cargo.lock file first time you run cargo build, so now we have this in the guessing game directory, and you can kind of see it. In fact, whatever. When you build a project for the first time, Cargo figures out all the versions of the dependencies that fit the criteria and then writes them to the cargo lock. When you build your project in the future, Cargo will see that the cargo lock file exists and will use the version specified there rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically. In other words, your project will remain at 0.85 until you explicitly upgrade. That's interesting. But that means when you build, because up here it says, where is it? The specifier 0.85 is actually shorthand for caret 0.85, which means any version that is at least 0.85 but below. Oh, okay. So semantic versioning, a patch version when you make backward compatible bug fixes, a minor version when you add. Okay. Semver, thank you very much. So you update the third number when when you're fixing a bug, you update the second number. When you add functionality, but you aren't making breaking changes, a major version means you made breaking changes. Okay. That's actually something to really keep in mind, because I've seen so many different versioning systems and I didn't know what they all necessarily meant. Like a lot of, like, if you look at game studios, it's like there's fucking build number out there. Jesus Christ. Like, oh, here's the build, here's the daily build at X 15 p.m. and then their version number creates a 6-character hash of that build. And like, what are you doing over here? So updating a crate to a new version, okay. Cargo provides the command update, which will ignore the cargo lock and figure out all the latest versions that fit your specifications in the cargo toml. Cargo will then write those versions to the cargo lock. Otherwise, is the cargo lock something you don't want to commit the cargo lock, do you? I can't imagine you do. Only look for versions greater than 0.85 and less than 0.90. If the RAND crate has released the 2 new versions 8.6 and 0.90, you'll see the following: updating the crates index, updating RAND 0.85 to 0.86. Cargo ignores the 0.90. You would also notice a change in your cargo lock, noting that the version of the RAND crate you are now using is 0.86. To use RAND version 0.90 or any version of the 09X series, you'd have to update the cargo toml to say 0.90. So basically, well, I'm used to situations where I'm like, I look at like game developers, right? A lot of game developers that I know, when they put out new versions of a game, they'll have like X.Y.Z, and their versioning system is basically like this. It looks like it's semantic, but it's not actually, because they just go 0 to 1 to 2 to 3 to 4, and they'll go all the way up to 9. But if they go up to 10, instead of actually doing 0.9.10, it would be 0. And then they'd add 1. And so this, instead of 0.10.0, it would go 1.0. That's... And you hear about video games all the time, like, especially now that you're in... Now that early access is a thing. It's like, oh, this game is going 1.0, guys. It's actually coming out now, especially if you're like if you're like me and you're a fan of Factorio. So the next, it's weird, but I like this. Just reading about it. Increment the major version, patch version. Yep. The world of suffering. Dependency hell. Got it. So there's a lot more to say about cargo and its ecosystem. Publishing on crates. Oh, there's another whole book, which we'll discuss in chapter 14. But for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so recitations. Let's start using RAND to generate a number. All right. I guess. Okay, let secret number is equal to that. So let's get rid of that change. Oh, I hate that it's... I need to fix that. If I delete something in NeoVim, it is actually putting it inside of my clipboard. That's instead of its own registry. I'm realizing that's what it's doing now. Oh, no. No. Dang it. There we go. So we're letting the secret number, no method, gen range. Wait, what? Oh, we need to... I'm not going to pull up the window. I need to bring... Oh. Copy and pasting code is the most difficult thing I'm doing today, isn't it? So standard IO, we're using random, we're using RNG, and cargo build, secret number. Oh, it's not, secret number isn't being used. Okay. And then we make the guess. We're printing the secret number. And then input the guess. Oh, and that's sweet, Hannylicious. You're my secret number too. Anyway, so IO standard in read line, and we borrow the reference guess. Then we say we failed to guess, and then we. Oh, okay, so for this step, I mean, I did just have a bad case of gastric distress that I needed to go BRB on the stream for about 5 minutes. Is that why you're here now? So we have our new string. We have our secret number, and we print the secret number. See, that's you're half a step ahead of me. Yes, we've all got jokes today. Why is it saying unmatched? It is absolutely matched. I don't know what. You know what? I'll just run with it. It's telling me unmatched. I hate. Okay, cargo. And we'll run that code. The secret number is 96, and we'll guess 10. And it says I guessed 10. Alright. So now, we bring back up our oh, you're going for alert? I appreciate the company for as short as the time I had you, Hanny. Let's see, now we're adding 2 lines to the middle. We call the thread ran. Wait. Oh yeah. So we print the secret number and we generate the secret number. But then we also import the RNG. Where are we at? Okay. First we add the line random, use rand RNG, the RNG trait. Trait defines methods that random number generators implement. And this trait must be in scope for us to use those methods. Salute to you, Hannylicious. I appreciate the anniversary party hat. Chapter 10 will cover traits in detail. Aha. We're adding 2. What the hell just... There we go. Testing the first part using a crate. I clicked somewhere that it said, oh, did you click somewhere? Let's send you to the very top of the book. Let's run the program. Is this... Uh-huh. Comparing the... No. Here we go. This is where we were. Adding 2 lines in the middle, we call the thread_rng function that gives us the particular random number generator we're going to use. Oh, okay, so thread_rng. So rand thread_rng, that's just calling, hey, we need to grab, random thread RNG, this is saying, hey, give us the actual generator of random numbers. Dot, we generate, and we range from 1 to 100, and I'm guessing the equal sign means inclusive. This method is defined by the RNG trait that we brought into scope. Wait. Okay. One that is local to the current thread of execution and is seeded by the operating system. Then we call the genRange method on the random number generator. This method is defined by the RNG trait that we brought into scope with the use rand RNG statement. Okay. The genRange takes a range expression and generates a random number. Hey, simple enough. The kind of range expression we're using here takes the form of start ... equals end and is inclusive on the lower and upper bounds. So we need to specify 1 ... equals 100. So I guess equals is inclusive, but the equal sign means inclusive to both sides? You won't know just which traits to use and which methods to function. So each crate has documentation. So we run cargo doc open command. Build documentation provided by all your dependencies locally and open it in your browser. In the rand crate, run cargo doc open and click rand in the sidebar on the left. Really? That's actually kind of fascinating. So if I do cargo doc open, so is it opening the file now? Okay, it opened it in my other browser that I don't show the rest of you, so I'm going to open it again here. So we have get rand. Oh, wow. Main. That's really interesting. That it automates, like, here is all the documentation of every. I was not aware of this. This is actually really cool. And the fact that it pulls it and stores it locally. Sully, if you're still here, like that's probably the most interesting thing I've seen yet, is you can just do cargo doc open and it pulls up document. It doesn't go to a documentation page on the internet. It compiles documentation on all of your libraries into a local HTML file. Holy shit, that is actually really cool. Unions, type A. Oh, and I get access to all of this data. Here's all my structs that I can use. I can just say, hey, what's XDP options? And that is stored locally as well. Huh. Oh, well, well, now it's getting into, like, what if I do doc? Ah, okay. Help.html? The Rust doc book. Settings.html? Dark. Ooh, I can flashbang people. Get, I guess, target. There's Rust doc fingerprint. Dev Rust, guessing game, target. Okay. So target, doc, settings. It can't be, no, it's not help.html. What file was it? Go all the way back. Okay, so it's doc guessing game. So we go doc, guessing game, index. We go main, and I guess because, what is the restricted visibility? Got it. That's actually kind of sick. Being able to pull up documentation on all the libraries I'm using is... like, I'm used to seeing that in... like, you can do help inside of the actual Python. Like, in the Python world, you can do help the thing. Like, you call the function help, and you give the help function the input of whatever your object is, and then it prints out like a help document in your terminal. But I've always had trouble reading those. So, man. Anyway, yeah. We go in and we check rand, IU. Rand provides utilities to generate random numbers. It's really cool. I don't know if you guys can see that. The second new line prints the secret number. This is useful while developing the program to be able to test it. The second new line prints the random... oh, yeah. We'll get rid of that eventually. Comparing the guess to the secret number. Now that we have user input and a random number, we can compare them. Listing 2, 4. Oh, my God. So then we say, once we've said you have guessed guess, we do a match statement. Another use statement. We say standard comparing and ordering. Okay. So let's copy that line. Ordering, and then we'll copy all of this. And then it says, okay, so let's look at what it does and see if we can. So we do a match statement, which I imagine, much like in C, from a pure like here's how you use it functionality, I'm guessing match is the switch statement, the switch case kind of stuff, and then you have your cases down here, where if it's less, you say that the number is too small. If it's greater, you say too big, and then you say you win. Here. Okay, so then cargo build. Could not compile guessing game. What did it not like? Secret number. Expected string and found an integer. You know what? I'm betting this is one of those. We're about to show you why it's gonna error out. Yep. It's supposed to error out because you need to cast. Yep. So you say let u32 guess trim parse expect. So we will copy this. Nope. Let guess. the lovely moments when you realize that... there we go. Let guess equals U32. Or let guess colon U32, which means guess is going to be a 32-bit unsigned integer. Equals guess dot trim dot parse dot expect. So then, if we say cargo build, could not compile. That's interesting. Guess compare, expected string. Oh, secret number. Expect, so we mutable guess. Expect failed to read line. The line is, we create a variable named guess, but wait, doesn't the program already have a variable? But helpfully, Rust allows us to shadow the previous value of guess with a new one. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables. Often used when you want to convert value from one type to another type. We bind this new variable to the expression guess.trim.parse. The guess in the expression refers to the original guess string. The trim method on a string instance will eliminate whitespace. Okay. Compare to the string in U32. The user must press. Okay. Any whitespace, which we must do to compare the string to an unsigned 32-bit, which can only contain numerical data. The user must press enter to satisfy read line, which adds a new line character to the string. For example, if the user types 5s and press enter, guess looks like 5\n. \n represents new line. The trim method eliminates the white space. The parth method on strings converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number we want by saying U32. The colon after guess tells Rust will annotate the variable's type. There's a few number types. U32 is unsigned 32-bit integer. Small positive number. You'll learn about other number types in chapter 3. U32 notation. Parse method will only work on characters that can be logically converted into numbers. Let's see. So why is it still not compiling? Actually, let's guessing game cargo build. Mismatch types. Guess CMP secret number. Expected string found integer. So if we go back to 1, so random, let secret number U32. Thread RNG generate range. Let guess be U32 guess trim parse expect. And so match guess, compare, secret number. Wait, what did I change on there? Okay. Oh, okay. Maybe I hadn't saved the file. Okay. So there's the compiler. Let's go back to our book. parse method. Let's run the program. Oh, yeah. Let's run the program. So cargo run. The secret number is 85. Let's guess 1. Too small. Secret number is 35. We'll guess 36. Too big. Cargo run. 64. Let's guess the exact number is 64 and you win. We've won, chat. We have correctly guessed the number. So back to our code. Everything looks kosher. Let's pull the book back up. Spaces were added before the guess. Oh, that's right. Well, allowing multiple guesses with looping. The word loop creates, the loop keyword creates an infinite loop. We'll add a loop to give more users more chances at getting the number. What is Tokio? Tokio is a asynchronous framework, or an asynchronous runtime. So it basically, strictly speaking, Rust has asynchronous stuff in it already, but for reasons that I'm not educated enough to know, if you're going to do asynchronous programming, it sounds like everybody tells you to use Tokio rather than the built-in Rust functionality. So the last time I streamed, which was on Wednesday, I tried to go through the Tokio book, and I realized, like, there's a lot happening in the Tokio book, and maybe the assumptions that I'm making going through the Rust book just aren't quite what I need. How many chapters is this book? 20. Oh, okay. So chapter 20 is building a multi-threaded web server. We can accept that. Okay. But yeah, Tokio is basically how people do asynchronous programming in Rust. As far as I know, it's not the only way, but it's sort of like, it's the way people tell you to do it. Like if Hanny was still here, he would tell you that if you want to do web in Python, pretty much everybody uses Django. Even though I use Flask, and I've thought about switching from Flask to Fast API. All right, so let's do a loop then. Let's do a loop then. So we want to loop the please input your guess. Actually, let's see. Secret number is this. Please loop. And we'll grab this. Please input your guess. And we'll make the guess that. Actually, yeah, there you go. And then we have the secret number, so let's generate the secret number up here. And that's where we actually take input. Actually, let's instantiate the guess object there. We print, hey, please input your guess. We take our 3 lines to actually read the data. We then trim that, parse it, turn it into an actual number, and then we match. We do our switch case, and then we say, we should probably say it up here, you guessed that, and there's a whole bunch of white space lines we can get rid of. So failed to read line, too small, too big. Okay. Now, cargo run. Guess the number. Please input your guess. 1 is too small. What about 50? Is too big. 25. Too small. 30. Too small. 40. Too small. 45. Hey, 45 was the number. Well, I won. Alright, so what does the book do? Okay, so we win, but it's actually still... let's see. Oh, that's right. We can do quit, and we can actually make the kernel panic. Got it. So then, typing quit will quit the game. Quitting after a correct guess. Okay, so we do a break to get out of. So equal is this. Oh. Get rid of the extra white space. Print you win. Break. So cargo run. Unexpected token. Because I needed a semicolon there. Please input your number. 1, too small, 50. Too small, 75. Too small, 90. Too big, 80. Too big, 76. 77. 78. 79. And we won. Oh, hang on. Gotta tell Mega Neko to get out of the way in a second. Hang on. There we go. So it says we won and it actually quit the program gracefully. That's really good for us. Means we're getting places and doing things. Now, let's go back to our code. Adding the break after you win makes the program exit the loop, which then once you get out of the loop, it goes to the end of the program and exits gracefully. Handling invalid input. To further refine the game's behavior, we say let U32. Okay. So we match, guess, trim, parse. If it's okay. Anything else is... what? Okay, so error... Alright, let's probably just go ahead and copy and paste that and see what it... So, back over here. Okay, so we let guess is U32. So we match. I don't know, why does it continue if there's an error? Why doesn't it exit? So we do a match case statement where we take the guess, we trim the white space, we parse it into a U32. Once we parse it, we can either get the OK, which is the actual value, and OK will contain the value num. Is there num anywhere else here? No. Okay, so OK means inside the parentheses we want to do the... Like, inside the parentheses is a name we are applying to the actual value output by the parse. Which then... we get the num, and then anything else, if there's an error, any kind of error, we just continue. And then we say, you guessed guess. Let me see what that actually does. 1, 2, 3. Big. Please type a number, % error. Okay. So it doesn't even get to the next... it doesn't even get to the print line where it prints out your guess. Oh, hang on. Yeah, we need to get rid of that. Let's try that again. 1, 2, 3, 50. Too big, 25. Not big enough. Oh, really? Continue. So the continue keyword means just go back through the loop, I guess. I think? Let's check the book. We switch from an expect call to a match to move from crashing on an error to handling the error. Remember that the parse returns If parse is able to successfully turn the string into a number, it will turn OK. If parse is not able, it will return an error that contains more information about the error. The error value does not match the OK num pattern in the first match arm, but it does match the error underscore. The underscore is a catch-all value. In this example, we're saying we want to match all error values, no matter what information they have inside of them. So the program will execute the second arm's code. Continue, which tells the program to go to the next iteration of the loop. Oh, okay. So continue is reset the loop and start over. Interesting. Is there Rust loop continue? Skip to the next iteration of the loop. When continue is encountered, the current iteration is terminated, returning control to the loop head, typically continuing with the next iteration. So if there were a ranged loop, like, hey, do this on these conditions. Yeah, okay. Here's the example. I'm trying to read ahead in my own brain. Printing odd numbers by skipping even ones. For numbers 1 through 10 inclusive, if the number modulo 2 is equal to 0, which, as a programmer, you know, if modulo 2 is your even test, 1 means it's odd, 0 means it's even. I don't have time to explain the modulo operation. If you're not a mathematician, modulo is a thing. So we continue, which means we go back and do 2. If number divided by 2, okay. So for number in 1 to 10 inclusive, if number modulo 2 is equal to 0, wait. Oh, printing odd numbers. We continue. So if not for 1, so we have the number 1 modulo 2 is not equal to 0, so we skip this, and then we go straight to print line. Now, since we've already done 1, we do 2. If the number is 2, if 2 modulo 2 is equal to 0, it is, so we hit continue, rotate back to 1. Got it. All right. Parse is not able to return the number. Continue rotates back and starts the next iteration of the loop. I hate this so much. There we go. If I get anywhere close to this level area of the screen, it prints out the bar, and then if I click in the bar, it goes back to the beginning of that. I hate it. Okay, after a correct guess. So here's our main. So then awesome, with one final tiny final tweak, we will finish the guessing game. Recall that the program is still printing the secret number. That worked well for testing, but it ruins the game. We already did that. Okay. So we'll copy that. Get out of our book. V-split. And then we'll just do main2.rs. So how does my... There we go. So secret number rand. Oh, I don't have an extra white space line. Please input your guess. Oh, they put that later. Oh, no. There we go. Guess is string.new. IO standard in. So I deleted a whole bunch of extra void space lines. Guess compare. That looks exactly the same. Okay. All right. What time is it? Where the hell's my... Oh, there's my phone. Hang on. Just a second. My phone is on my other desk. And I'm back and I realize it's now 9:30, so let's keep going. Let's bring the book back up. There she is. So summary, this project was written on a hands-on way to introduce you to many concepts in Rust. Let, match functions, the use of external crates, the use of like promises and all that. These concepts in detail. So we have data types, variables, data types, and functions. How to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other languages. Chapter 5 discusses structs and method syntax. Chapter 6 explains how enums work. Okay. Actually, before we start the next chapter, but let's go ahead and load it up. Common programming concepts. I'm gonna go be right back again. My throat is starting to dry out a little bit. I need a little refresher of my drinky drink. Be right back. I'll see you guys in just a second. Ah, okay. I got my drink. Take a sip. Good stuff. All right. So let me just double check on some bookkeeping here. Some minor bookkeeping work I've got on my end. Hope everybody's doing okay. If anyone has questions, well, I probably try to answer them myself, but I might not have the answers. So, what do we got? What's our position? So we have common concepts in programming. Chapter covers concepts that appear in almost every programming language and how they work in Rust. So this is also one of those situations where it is really, there's a lot of decisions that got made in Rust that are kind of hard to wrap my own brain around. I'm really interested to see, like, I want to say that when I looked up how many different types of strings, there was something like 5. In Rust's standard library, there are 5 different types of strings, and that's fascinating to me. Like, I could definitely see, like, heap allocated versus stack allocated. I guess mutable versus immutable, but then that's a thing inside of Rust itself. So let's see what happens. As mentioned in the storing values of variables section, by default, variables are immutable. This is one of many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability, and why sometimes you might want to opt out. Alright. So let's make a new project, cargo new variables. So let's back out of here. Cargo new variables. And then variables. And so now we're getting out of okay, so bang. Get out of guessing game and get into variables. Open Vim and open the cargo, the source main. All right, so we have our beginner, like, hello world program. We have that. Let's see, then in your new variables directory, open main.rs and replace its code with the following code. So let's delete all this. Ooh, let's... Oh, nope, there we go. That song's a little on the loud side. There we go. Let's copy this. Actually, just copy all of it. And paste. And yet it's not saying that we have a mismatched thing. That's super weird. Anyway, so let x equals 5, value of x equals... and then there's that. Then we say x equals 6. This probably doesn't compile, but let's just say cargo build. Cannot assign twice to a mutable variable. So we have to make it mutable, I bet. Let mute cargo run. Okay, but if it's not mutable... Oh. Yep, cannot assign twice to an immutable variable. Keep that in mind. So let's see what the book says. Save and run the program using cargo run. You should receive an error message, immutability. So then we say, yep, we let it be mutable. Constants. Like immutable variables, constants are values. Yep. Constants are values that are bound to a name and are not allowed to change. But there's some key differences. First, you aren't allowed to use mute with constants. Constants aren't just immutable by default. They are always immutable. Always immutable. You declare constants using the const keyword instead of the let keyword, and the type of the value must be annotated. Must in italics. Cover types and annotations in the next section, data types, so don't worry about the details right now. Just know that you always have to annotate the type. Constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of code need to know about. Including global scope, which makes them useful. The last difference is that constants may be set only to a constant expression, not the result of a value that could only be computed at runtime. So here's an example of a constant declaration. 3 hours in seconds, U32, 60 times 3. The constant's name is 3 hours in seconds, all in capital letters with snake case. And its value set to a result of multiplying 60, the number of seconds in a minute, by 60, the number of minutes in an hour, and 3, the number of hours we want to count in this program. So it can't be something you compute. It has to be something you compute at compile time rather than at runtime. The naming convention is for all constants is to use all uppercase with underscores between words. Yep. Caps lock snake case, in other words. The compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write out this value in a way that's easier to understand and verify, rather than setting this constant to the value 10,800. Rust reference section on constant evaluation. Okay. Constants are valid for the entire time a program runs. So, within the scope in which they are declared. This property makes constants useful for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn or the speed of light. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of that value to future maintainers of the code. So it's mostly, it's admittedly, declaring a constant is mostly a documentation thing rather than an actual technical thing. Even though it's partially a technical thing, but it is more, it's more documentation, but it's documentation with guardrails. Whereas a mutable variable, you can still kind of sort of fuck with a mutable variable, but you can't, but you don't want anybody to fuck with your constants. It also helps to have only one place in your code you would need to change if the hard-coded value needed to be updated in the future. Okay. So, as you saw in the guessing game tutorial in Chapter 2, you can declare a new variable with the same name as the previous. Rustaceans say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it itself is shadowed or the scope ends. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. So let's copy that. Let's paste. Get rid of that. So we say let x equals 5. Wait, what? So let x equals 5, let x equals x plus 1, which theoretically should be 6, but actually let's... that's not going to compile, is it? Really? Let x equals 5, let x equals x plus 1. Why does that compile? Oh, okay. So by saying let, I guess we're declaring a new value and using the name to point to the new value. But then I guess, does that kill this value in memory? So I'm reading ahead here, but according to lifetime, according to Rust lifetimes, we're doing this here. Let x equals x times 2. So we're grabbing, let me grab this, print it, the old value of x, and then the new value of x in the inner scope. So then if we go to 2, we run it. So you see the old value of x in the inner scope is 6, the new value of x in the inner scope is 12. And so we're using the same name. So we're pointing, I guess it doesn't because it's killing the original value, but then the new name, but then the name, because that the new, okay. Here's the old value. At this point the old value is 6. We hijack the name here, we hijack the name there and assign it to the new value, which it was 6. As of executing that line, it becomes 12. Then we print that 12, and then the scope ends. This block of code, this scope ends, which means we kill the value of 12. So then x then goes back to being 6. So where is 5? Is 5 dead? I don't think it should be dead. Hang on. FN kill x. So it shouldn't return anything, but it should take a x print line. We are killing the value of x. Right? And then we say, we double that, and then we kill x. I guess we'll give ownership. X. Line 18. What is it saying it's missing? Column 12. Line 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. X U32, I guess. Now, cargo run. Really, we're not killing X, actually. That's fascinating. Let's pull up the book again. Kill variable rust. To delete an object before the end of scope. Print line, dropping noisy. Self. Transfer ownership. Wasn't there a piece somewhere in this book? Spaces, length. Mutate a variable's type. No. Data types. Integer overflow. There was a thing where, let's see, destroy value rust. Force a value to be dropped at some point. Let y equals my thing. Match 1 is left and true. You could also move y into the scope. Break. Destructors. Oh man, I saw that there was a destructor. There's a rust reference. Okay. There's drop scopes, each variable. I remember there was distinctly a way, like you could actually give ownership. Actually, what if? Okay, expected U32 found. Oh, hang on. Instead of that, we borrow. Consider borrowing here. Okay, so we're not actually killing X. So I have to imagine that 5 is still instantiated in memory somewhere. Variables and mutability. Let's go on with the lesson. I think it should probably help me figure this out. Okay, so program first binds x to a value of 5, then creates a new variable x by taking the original value and adding 1. So the value of x is then 6. Within an inner scope created with curly brackets, the third let statement also shadows x. Multiplying the previous value by 2. When we run the program, it will output the following. Shadowing is different from marking a variable as mute because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on a value, but have the variable be immutable after those transformations have been completed. I don't like this word here that they use. They said variable. It would probably be better because they are really trying to drill the distinction between the variable's name and the variable's value as entirely separate concepts. Whereas shadowing, we retake the name of the variable and we assign the name to a new value. I don't know if that means the original value is still instantiated in memory, but now it just no longer has a name. Or if it kills the old value, because that's the question I'm really curious about, is what happens to 5? Are we actually, because we're not mutating 5. Because we're not mutating 5 because we didn't instantiate it as a mutable value. We're not mutating it. So then we're hijacking the name by saying let, right? We just take X and give it a new value by saying, here's the old value of X, take the old value of X, add 1 to it, instantiate that as a new value, and assign the name X to it, therefore kind of hijacking it. We create this scope, we print the old value of X, which means we grab 6 and we print it, but then we hijack the name all over again, and we double it and we get 12. We can see that we printed 6, and then we say the new value of X is 12. So then we grab the new value of X. Then in the scope, because the scope ends, the value that we had assigned in memory, the value of X, or no, the value of 12, that gets killed in memory. That means, like, in memory it is freed up. Any other piece of code can use that memory address. And then by that token, the variable name of X then gets reassigned back to the old 6 value. Oh man, I'm breaking myself here. So then we say we're printing the value, we're printing X. We try to kill it, but we can't kill it. That's a very interesting, because, you know, I said we're killing it, but then I printed it again. That means it's not killed. And I've tried to kill it, but I cannot. Oh, is it? What about expected? Oh. Okay. Print line, we're killing the value of X. Very, very interesting. So, other differences between mute and shadowing is that because we're effectively creating a new variable, when we use the let keyword again, we can change the type of the value, but reuse the same name. For example, say our program asks a user to show how many spaces they want between some text by inputting some space characters. And then we want to store that input as a number. The first spaces variable is a string type. Shadowing thus spares us from having to come up with different names, such as spaces string and spaces num. Instead, we can simply reuse spaces. However, if we try to use mute for this as shown, we'll get a compile time error. Why not? Let's go ahead and do that. Let's print. Let's get rid of that. Cargo run. We're saying mismatch types. We're mutating the value expected due to this value. We expected some type of string. Yep, they expected the string and found a U size. Try removing the method call. Okay. So then, if we do that... Nope. And then we cargo run it again. Okay, so even if it's not mutable, it doesn't work like that. So instead, we say let mutable spaces is equal to all of a bunch of white space, and then we say let spaces equals space.length. We'll do that. The value of spaces. And then we'll grab that. Cargo run. The value of spaces is a whole bunch of white space, and then the value of spaces is 3, because it's 3 white spaces. And we call spaces.length. The error says we're not allowed to mutate a variable's type. Yep. Now that we've explored how variables work, let's look at more data types they can have. U32 is the string literal of 42. We parse that into a number and expect it. And if it's not a number, then it says it's not. Then we print not a number. We don't add the colon U32 type annotation shown in the preceding code. Rust will display the following error, which means the compiler needs more information from us to know which type we want to use. Scalar represents a single value. Rust has 4 primary scalar types: integers, floating point, numbers, booleans, and characters. Okay. You may recognize these from other programming languages. Okay, so we know I8 is 8-bit. 8-bit, we have signed and unsigned. I'm going to guess that signed means 2's complement. Oh, yeah. Signed numbers are stored in 2's complement. I'm reading ahead, ladies and gentlemen. Signed variant can store numbers from -2 to the n-1 power. Oh yeah, inclusive. Integer literals in Rust. You can write integer literals in any form. Literals can be multiple numeric types to allow type suffix, such as 57U8. So it's the number 57 stored as an unsigned 8-bit to designate the type. Number literals can also use underscores as a visual separator to make the number easier to read. So whereas Americans would use commas, and everywhere else that hates freedom uses dots to separate 3 digits, computers have decided to meet in the middle and do the ugliest thing possible and use underscores. So basically, 1_000 is the same as 1000, and the underscore is just there for visual separation, because like hell I'm gonna look at 9 zeros and try to parse out what that means. How do you know which type of integer to use? Oh, that's... Ladies and gentlemen, I'm going to need to keep in mind is that if you want to store a string as bytes, lowercase b, single quotes, and then there's your string, your capital A. Does that work with... Oh. Does that work? Let byte string equals b, abcd, and then we print the value of byte string. Oh, wait, no. Character literal may only contain 1 code point. Okay. So if I put it in double quotes instead of single quotes, can I have a string? I can. So byte string byte char. Right? And then so that's just a byte char. So cargo run. U84 cannot be formatted. Display is not implemented. So we can't print the actual byte string. Or we can't compile the byte string. Even though the editor and the language server is not giving me any guff about this. What if I don't print it? No, not. If I don't print it, does it care? It gives me a warning and says that it, Really? So if that's interesting. So byte char is 65, which is the hang on. ASCII chart. ASCII printable characters. Yep. Capital A is indeed the number 65 in ASCII. Okay. So when you store as a byte, you are only actually storing the 8 bits that would be A in ASCII, but you're not signaling to anything else. Hey, this is an ASCII character. Got it. There's some kind of signaling happening somewhere that says, hey, this is supposed to be an ASCII code, so if you're printing me, then here's what you need to do. Octal is 0077. Okay. So we also have floating point types. 32-bit floating point, 64-bit floating point. Floating points are default to 64-bit. IEEE 754. I don't know what. I should probably look that up at some point. But a floating point number means you can have decimals. It's kind of complicated, but not that complicated. F64 has double precision. Numeric operations. We can do addition, subtraction, multiplication, division. Pretty standard stuff. Don't even need to review that. T equals true. F bool equals false. Yep. Character type, we have C is... So characters are... So characters are single quotes with explicit type annotation. Oh yeah, explicit type annotation, and then hard-eyed cat, we can actually print emojis. Note that we specify character literals with single quotes, as opposed to string literals, which use double quotes. Rust's character type is 4 bytes. Really? Unicode, oh okay, because it's Unicode, it's not actually ASCII, it's Unicode. It can represent a lot more than just, yeah. Accented letters, Chinese, Japanese, Korean, emoji, and 0 with spaces are all valid character values in Rust. Oh, throat's starting to get parched again. Unicode 0 to Unicode D7FF. and then E000 to 10 FF, or one, not 10 FFF, but 10 FFF inclusive. A character isn't really a concept in Unicode, so your human intuition for what a character is may not match up with what a char is. I'm used to C, where char as an explicit type is Unicode, which is 1 byte? Yeah, 1 byte. Rather than 4 bytes. We'll discuss this topic in detail in Chapter 8 for storing UTF-8 encoded text with strings. Compound types. So a tuple is a general way of grouping together a number of values. So parentheses, as we're declaring, as we're saying explicit types, we want a tup, and the type of tup will be a tuple of first an integer of 32 bits, a signed integer, a 64-bit floating point, and an unsigned 8-bit. Which a 32-bit integer certainly fits 500, 6.4 fits with 64-bit floating, and 1 for an 8-bit. So we say let tup equal 500, 6.4, and 1, but we're not declaring it explicitly. So then we'll let the 3 tup values, x, y, and z is equal to tup. Interesting. Now I want to know, is that borrowing? Or is that declaring a new thing in memory? I guess, are we cloning, or are we... I guess let means we're instantiating a new object. I'm going to keep saying object, even though people got on to me for saying object in Rust. I'm going to keep saying object. Screw off. Let x, y, and z is equal to tup. Value of... Actually, we can test that. We can just test it. So let's copy. And then we'll paste. No. No. We'll paste fn main. Ah. Okay, byte string. We'll get rid of all that. Get rid of that line. Get rid of that line. Let tuple. We'll grab all of these. So we have 500, 6.4, and 1. We let x, y, and z is equal to tup. Print line. Let x equal 499. Print line. The value of tup1 is, I guess, tup. That's my guess at how you would do that. Error expected. Let x equal 5. Actually, instead of that, the value of y is that... What if we cargo ran it? Expect... Interesting. Rust access members of tup. Of a tuple. Access individuals... String Ricky. Okay. Colon question mark, and then you say tuple. Got it. So colon question mark. Tup. This is intentional. So the value of I is 6.4. Tup. The value of XYZ is that XYZ, I think. So then that would be, nope. Okay, so we have a tuple, XYZ, and it's set to 506.41. But that doesn't fuck with the actual tuple, actually. Right. So we print it twice. We have XYZ in tuple. Then we change the value of X. And the X inside the tuple actually changes. We're not actually, we are shadowing, but then the tuple isn't really instantiated as a thing. Let's see. So if we do let X equal 499, let Y equal to 5.3 or 5.1, let Z equal to 4. Yep. So the tuple, I guess, only really exists during instantiation. I'll let the... I should probably... Yeah, there you go. That way it's more visible there in case the song track changes. So we instantiate an actual tuple itself, and the tuple only exists if it's instantiated as a tuple. But because we instantiate a tuple literal, I guess, then the three values still exist as values themselves, but without without having a way to reference the tuple as the tuple itself. But then that also does, in fact, mean that the tuple, that these don't get killed. It's not, what's happening here is not shadowing, it's not killing. It is, tuple still continues to exist. These three values still continue to exist. We are cloning them and instantiating new things in memory and cloning them from the old values. So we have tuple, which is technically one variable. Inside the container, there's three variables. There's 500, there's 614, and there's 1. And then we're instantiating three new variables, even though we're treating it as a tuple, and using the tuple to do it. At which point we then print the values to prove that they exist and prove what those values are. We then separately shadow X, Y, and Z as separate instantiations. So we've reinstantiated another three values, and we've shadowed X, Y, and Z all separately. We're printing X, Y, and Z as a tuple. But since they're all changed, they're even still changed inside the tuple. I'm probably confusing anyone who's listening to my voice. But the original instantiated values of 506.4 and 1 still exist. Got it. Back to the book. Let's get rid of the Rust tuple. Let's see. This program first creates a tuple and binds it to the variable tup. It then uses a pattern with let to take tup and turn it into 3 separate variables, x, y, and z. This is called destructuring because it breaks the single tuple into 3 parts. Ah, okay. Finally, the program prints the value of y, which is 6.4. We can also access a tuple element directly by using a period, followed by the index of the value we want to access. So, we print x, y, and z. We print the full tuple. Actually, the value of the full tup. The 3 values inside tup are, and then we just say tup.0, tup.1, tup.1, and tup.2. And then we can just get rid of that. That's in, oh, what? Expected. The 3 values inside tup are, wait, really? Hang on. X 5_100 is x.0, x.1, x.2. The 3 values. What if instead of that, and then, and then those 3 values are, comma, tup.0, tup.1, tup.2. The auto formatter jump scared me for half a second. Okay, 500, 64, and 1. What if I say let tup.0 equal 498? Column 12, 1, 6, 7, 8, 10, 11, 12. Unexpected type. Let tup.0. So I can't fuck around inside of the tuple. I can't shadow. Okay, what if... Cannot assign. Okay, so what if I said what if we made tup mutable? Okay. Consider changing this. Okay. So back to the book. Array type. Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Unlike arrays in some other languages, arrays in Rust have a fixed length. Values in an array as a comma-separated list inside square brackets. That's an array in any other language. However, let's see. Arrays are useful when you want your data allocated on the stack rather than the heap. I took classes. I know what stack and heap are. We'll cover that later then. Arrays are more useful when you know the number of elements you will not change. However, for example, if you were using the names of the month in a program, you would probably use an array rather than a vector because you will know it will always contain 12 elements. Okay, so a vector is very specifically a list of values, but the vector can be fucked with. You can insert, you can extract. An array is a constant length vector, I guess. You write an array's type by using square brackets with the type of each element, a semicolon, then the number of elements. Okay. So let A, signed integer, 32 bits, gonna be 5 of them, and there's the 5 values. You can also initialize an array to by specifying the initial value followed by a semicolon and the length of the array. The array named A will contain 5 elements that will all be set to the value 3 initially. This is the same as writing, okay, as let A equal array 33333, but in a more concise way. Accessing array elements. Yeah. Let A, let the first. In this example, the variable named first will get the value 1. Because that is the value at index 0. So, can I make, let's copy this, paste it. So let A is that, let mutable first equals A0. First equal, actually, let's print line the value of first is first. And then we'll say first equals 10. And it, what? Expected, oh, okay, hang on, what? Oh, semicolons. Chat, you really need to, you need to get better about these semicolons. I don't know, it's like, I know I'm the one programming here, but you guys need to be better about these semicolons. I don't know what, it's amateur hour. That's what it is. It is just absolute amateur hour. So the value first, can we print of A? If we just try to print A, I don't know what it's gonna do. It doesn't like it. Cannot be formatted with the default formatter. So how about colon question mark? Oh, no, hello. A. So we didn't change the value of first. We didn't, we did change the value of first because first was mutable. So then if we get rid of mutable and then we just say let and we shadow first. Okay. We still instantiate a new value. Well, okay, there's a subtlety of what's happening here that's not going to be readily apparent. So what I did originally was I created a new variable that has the name of first and the value of 1, which is the first value of A. which is A0. And then I made it mutable so that I can change that value. So now, in this line, I actually changed the value that's in memory. That value, that memory address no longer says 1. That memory address says 11. Then I modified the code a little bit, and I said let first equals 11, in which, in this case, a new instance in memory of first, and we've hijacked the name of the variable first and assigned it to this new thing in memory. I still haven't wrapped my head around whether or not the original value for first, which is that 1 that's somewhere in memory, still exists. Does it get killed because it's like moved out of scope or whatever? That's gonna bug me until somewhere in the book probably will help me understand it at some point. But back to the book. Oh, there's a lot here. Okay. In this example, an array is a single chunk of memory of a known fixed size. So I guess arrays are they said arrays are stack allocated, didn't they? Okay. So the big key difference is an array is allocated on the stack and a vector is allocated on the heap. You write an array's type using square brackets with each semicolon. Okay, yeah, we covered all that. Variable name first. Let's see what happens if you try to access an element of an array that is past the end of the array. Say you run this code similar to the guessing game in chapter 2 to get an array index from the user. Let's copy that. Let's paste it. And let's delete all this. Save it. Cargo run, and it doesn't like it. Oh, wait, hang on. There we go. Please enter an array index 0, 1. The value of the element at index 1 is that. So then how big is it? 5. So we would want to say 5, 6, anything past the number 5. Because remember, we're programmers. This is space 0, this is space 1, this is space 4. Remember, programmers count from 0. So we're gonna say space 6. And it panics because it's like, oh god. The length is 5, but the index is 6. So then if we also say 5 again, the length is 5, but the index is 5. Cargo run 4. The value is 5. Okay, so let's just pretend. Well, no. I've done enough to do the basic. Here's what a programmer thinks. Code compiles successfully. Program resulted in a runtime error. Okay, yeah. You can't overflow an array. Functions. Okay. This is how you declare a function. We have another function. Parameters. So in parameters, you can say, oh, hey, another function takes a variable which we're going to call x inside of the thing. And because we have a colon, we declare that it can only take signed integers of 32 bits. We print that out. Yep. Declaration of another function. So then we say, in the main function, we call this function print labeled measurement. We have a value, which is a signed 32-bit, and a unit label, which is a character. And the measurement is 32, signed integer 32-bit, unit label is character, and it's character because it's single quotes, da-da-da-da. Simple enough. Statements and expressions. Okay. Function bodies are made up of a series of statements, optionally ending in an expression. So far, the functions we've covered haven't included an ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, this is an important distinction to understand. Other languages don't have the same distinctions, so let's look at what statements and expressions are and how their differences affect the body of functions. Statements are instructions that perform some action and do not return a value. Expressions evaluate to a result value. Okay. We've actually already used keywords. Why did I say keyword? Oh. Brain. Use statements and expressions, creating a variable and assigning a variable to it with the let keyword as a statement. In listing 3.1, let y equals 6 is a statement. That's a statement. You do a thing. Function definitions are also statements. The entire preceding example is a statement in itself. Statements do not return values. Therefore, you cannot assign a let statement to another variable. As the following code tries to do, you will get an error. Let x equal whatever is returned when you let y equal 6, but because it returns nothing, it says fuck you. When you try to, it says it uses a whole lot of text to say fuck you. Don't try to assign a variable to a statement. Wait. Is a function a statement? Can you say that a function is a statement? No, okay. A function should be an expression. Optionally ending is an expression. So a function can be an expression itself. Can be. Can a function be, I guess... so a function can either be a statement or expression. Give me a second. Are those two mutually exclusive? They are. A statement very explicitly does not return a value. An expression returns a value. They are mutually exclusive. I guess that's the definition. It's like, oh, if it's not a statement, it's an expression. Let y equals 6 statement does not return a value. So there isn't anything for x to bind to. This is different from what happens in other languages such as C and Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equals y equals x is 6. Have both x and y have the value of 6. That is not the case in Rust. Expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. Consider a math operation. So, let y is equal to, and then, because this is basically a function because it creates its own context, or scope, I guess is the right word. Let x equals 3, we evaluate x plus 1, so 3 plus 1 equals 4. By the end of that, y would equal to 4. And x would disappear because it goes out of scope. Let x equals 3, x plus 1 is a block. Okay. Functions with return values. So, fn5, you call the function of 5 and it just returns... It just returns 5. You know what? I'm into it. That's an efficient use of code space and memory. The arrow is supposed to say, like, when you declare, it's like function 5. It's going to return a 32-bit signed integer. A feature like that either recently got introduced to Python, or I didn't pay attention into Python for a long, long time. And it's always been there, and I only just learned of it recently. Function main, x equals 5. You can print that. Let x equals 5. Let x plus 1, 5. Okay. You don't have to say return, but you can. I'm going to say you probably should still say return, just for clarity's sake. Let's see. X equals plus 1, print line. Compiling this code produces the error. Where was the error? Is this a case of like borrowing? Implicitly returns as its body has no tail or return expression. Oh, is it because it's a semicolon? So you would either remove the semicolon or say return. Okay. Comments. Their comments are C based. I know how comments work. If and else work the same way in C. Number. If number. Okay, what does if number mean? You know what? Let's test. So let's copy. And we will paste. Oh. So let number was 3. Let 0num equals 0. If 0num. Yeah, because there's a weird thing in. There's a weirdness in C where if you evaluate a piece of memory, a variable, false is 0 and true is anything that's not 0. I just want to test to see if that's the case here. Expected bool found integer. Wait, really? Oh, did it say it doesn't want to compile? At the condition. Okay. The error indicates that Rust expected a bool. Okay, Rust doesn't need. Rust don't fucking play that game. Running this code. Okay. So Rust tells you to fuck off and not play this game with him. If number modulo 4, number is divisible by 4. Okay. So we're doing modulos, multiple conditions with else. I'm used to else's from every programming language. Using if in a let statement. Ooh, does that mean it evaluates to a number? If condition 5, else 6. So condition is true. Ah, okay. Got it. Got it. Actually, let's go ahead and copy that just to demonstrate. So value number is 5, and then we say if condition is false. It doesn't like that stop it. Value the number is 6 because we're false. If condition 5, else 6. Oh, it really does. It doesn't like me trying to separate that into separate lines. Maybe. Whoop. else 6. Nope, really doesn't like it. The auto formatter says no, fuck you. That code is ugly as sin, and we're not going to accept it in this house. Else. Can you do conditions? No, okay. They can't be separate types. So they do need to, wait. Can they never be separate types? Or is it, do you have to make some kind of, have value types that are incompatible? Where to find the problem? Could not compile branches, okay. The expression in the if block evaluates to an integer. The else block evaluates to a string. Rust wouldn't be able to do that if the type number was only determined at runtime. Okay, so for memory safety's sake, you can do unsafe, but for the sake of memory safety, we're gonna say during compile time, any kind of if needs to return both types in both scenarios. Which I guess is why the enums exist. Repetition with loops. That's a print. Print it over and over continuously until we stop. Quitting after a correct guess. So result equals loop. One of the uses of a loop is to retry an operation you know might fail, such as checking whether a thread has completed its job. You might also need to pass the result of that operation out of the loop to the rest of your code. To do this, you can add the value you want returned after the break expression you used to stop the loop. That value will be returned out of the loop so you can use it as shown here. So there's mutable counter 0. Let the result is the loop. Counter 1. Oh, okay. I guess break counter times 2. Let me just... yeah, copy that. Paste. No, hang on. So mute counter 0. Result loop counter plus 1. Counter equals 10. Then break counter plus 12. Let's see what that actually... Result is 20. So if the counter is 10, we return counter times 2. And then we print the result. So break is kind of similar to return. Then inside break is kind of like return, but inside of a loop. On every iteration of the loop, use the break keyword with the value counter times 2 after the loop. Okay, when it is, we use break. After the loop, we use a semicolon to end the statement that assigns the value to us. Yes. So loop, there's the loop, there's the open squirrel, there's the closed squirrel, and there's the semicolon to say this is the end of the assignment to result. Loop labels to disambiguate between multiple loops. Really? Oh, okay. So looping inside of a loop. Interesting. Let's copy that. Go back to our code, paste. Oh, nope. So we run that, count 0, remaining 10, remaining 9, count 1, remaining 10, remaining 9, count 2. Okay, so what is that actually doing? So we count 0. Don't know what the single quote is for, but counting up loop. Print line what the current count is. At this point, it's 2. We have mutable, which we'll call remaining. If remaining is 9, we break. And if count is equal to 2, we break from the outer loop. Huh. But break isn't, but that's not a return. So I'm confusing myself. In the previous example, break was an actual example. Huh. Interesting. So we have, or break was actually also signaling the return. Now it's not signaling the return, or is it? So this is just a loop. What if we get rid of the malformed loop label? So it's basically saying break this loop, and because of the single quote, that's what Rust knows, that this is a loop, but we're giving the loop a name. Fair enough. All right. Conditional loops for while. I'm going to guess while just works the same as any other language. But I guess while you need to give it a mutable thing. Is there a... Well, the condition is true. Whatever condition you give to while, it needs to either exist as a thing that can be evaluated. Okay, it needs to be exist as a value that can be evaluated, which assumes that evaluating, you're either giving it a mutable value, which hence, you know, we did give it a mutable value, or there's a, I don't know how to say it. Is it, I guess there is no other way to say it. It's, you're giving it a mutable, you're giving it something that's mutable. So this construct eliminates a lot of nesting that would be necessary if you used loop, if, else, and break. And it is clear. While a condition evaluates to true, the code runs. Otherwise, it exits the loop. Looping through a collection with 4. I imagine 4 just... Well, index is less than 5. Yep, for element in A. Works the same way as in Python. Got it. We run this code. 4 number in 1 through 4. Actually, let me... Because I didn't see the equal sign, it's probably not mutable. So... Right, 3, 2, 1. Okay, so if I said equals here, yep, that would be inclusive, but because there's no equals, it's not inclusive. But we still start at 1. I just want to see what that does. No, that's silly. Okay. So we give it an actual start. And then we say inclusive for... Got it. This was a sizable chapter for if statements. Or wait. Control flow. If, while, for, all that stuff. Understanding ownership. Whew. All right, I've been going for 3.5 hours now, and it's 11 in the evening, so I think I'm going to go ahead and call it there. because I need to decompress just a little bit. And I want to see what's going on. Let's go to